Today's lesson is sums and products of rational and irrational numbers. So much of today's lesson is actually an investigation that will be conducted by you. We are going to investigate what happens when we take the sums and products of rational and irrational numbers in respect to closure, which we learned about earlier in this chapter. So for the opening exercise, it says with a partner, but you will be completing this on your own. You will complete the tables to answer the following. Are the sets of rational and irrational numbers closed under multiplication? And what about under addition? So you're going to see there's a table for 1, and then there's a conclusion spot underneath. There's a table for 2 with a conclusion underneath. And then there's a table for 3 with a conclusion underneath. So at this point, what I would like you to do is pause the video, and you're going to complete the opening exercises, 3 tables. When you are ready, please resume the video to check your answers. I will have the answers posted, and we will discuss the results. So now that you've had an opportunity to try the opening exercise on your own, let's go over the answers. In number 1, you are examining the products, which means multiplication, of 2 rational factors versus looking at the product of 2 irrational factors. So on the left, when you multiplied 2 rational numbers, your result was rational for all 4 boxes. On the side with product of 2 irrational numbers, you can see that in 2 spots, the top 2 boxes, we still ended up with an irrational number. But when you take a square root and multiply it by itself, like square root of 5 times square root of 5, you get 5, which is rational. And similarly underneath, 2 square root 2 times the square root of 2 ends up being 2 times 2 or 4, which is rational. So when you have to circle one of the bolded words, the first sentence should read, the product of 2 rational numbers is always rational, because all of the answers stayed in the rational subset. Therefore, we can say that it's closed. On the other side, the product of 2 irrational numbers is sometimes irrational. And you can see I've marked them on the side. So that means that the product multiplication with irrational numbers is not closed. Now let's look at addition. Here on the left-hand side, you had to take the sum of 2 rational numbers. So a rational plus a rational. When we did this on the left-hand side, all of the boxes ended up still having a number that was a rational number. On the other side of the table, you have the sum of 2 irrational numbers. Here you can see the one spot where we veered from having an irrational result. So when I did 3 square root 5 plus negative 3 square root 5, because they are opposites of each other, they equal 0. And 0 is a rational number. So when we complete our sentences below, the sum of 2 rational numbers is always rational. So that means the rational numbers are closed under addition. When we look at the right-hand side of the table, taking and adding 2 irrational numbers, we saw that it wasn't consistent. So here, the sum of 2 irrational numbers is sometimes irrational, which means that irrational numbers are not closed under addition. Moving on to table 3. What kind of numbers are the product and sum of a rational and irrational number? So let's look at each side of the table first. On the left side, we're taking the product, which means we're multiplying a rational and an irrational number. So you can see we get a mixture of irrational and rational. On the other side, we have sum, which is addition of rational and irrational numbers, and all of them resulted in an irrational number answer. So when we go to our conclusions and we look at the left-hand side with product, the product of a rational and an irrational only is sometimes irrational, where the sum of rational and irrational on the other side was always irrational. However, if you look at this in the big picture, if we're taking a rational number and an irrational number, we're essentially working with numbers in the real number system. So make sure you add that at the top, right here. That really, if we put those 2 groups together, we're looking at the real numbers. So our last conclusion that we need to make here is that real numbers are closed under addition and multiplication when you look at the big picture. So now we're going to go through some always, sometimes, never questions to go ahead and finish summarizing What happens when we are checking for closure in these situations? So, based on your conclusions on the previous page and above, which of the statements is always true? Which is sometimes true and which is never true? If the statement is sometimes or never true, give an example to support your reasoning. So the first one, the sum of a rational number and a rational number is rational. So in other words, rational numbers are closed under addition, and we did find out that that was always true. In B, the sum of a rational number and an irrational number is irrational. So if we really want to go back and check it out, a sum of rational and irrational is always irrational. That's this table here on the right in number 3. So the answer to that is always. In C, the sum of an irrational number and an irrational number is irrational. So two irrationals added up. So if we go here, we remember I had the one exception that was rational. So this is going to be sometimes true. And if we want to have an example of that, we have the example of what we call additive inverses. So for example, if I take the square root of 2 and I add to it the negative square root of 2, I'm going to get 0, and 0 is actually a rational number, an answer. The product of a rational number and a rational number is a rational number. This is always, which we saw in our table. E, the product of a rational number and an irrational number is irrational. So we're going to go back up to product. Do we have rational and irrational? We do, rational and irrational right here in table 3. And we see that it is sometimes. We do have the exception of our example, which was square root of 2 times 0, which gives us 0, and there we see 0 is a rational number. And then lastly, the product of an irrational number and an irrational number is irrational. So that's irrational times irrational. So if we go back and look, that's this table in number 1 on the right, and we see there were exceptions to that. So again, the answer to this one is sometimes. And we have the example of, for example, square root of 5 times square root of 5. That was equal to 5. That's a rational number. Or we could have the one that was square root of 2 times 1 over square root of 2. That would be 1. So we're seeing that we can get a rational answer from that situation. Okay? And that concludes your lesson on sums and products of rational and irrational numbers.